We will now proceed to the last part of our lesson, which is inheritance. In the context of programming, inheritance refers to derived classes. Now, talking about classes, we've already touched a few things about classes. For example, we've mentioned classes for input and output routines, such as the iStream and OStream classes. Let's say the cin was derived from the iStream class. Same also applies for the input file stream, which is a derived class from the parent class input stream. Thus, derived classes are obtained from another class by adding features. The class of input file streams is derived from the class of all input streams by adding member functions such as open and close. As we've seen from the previous examples, we were able to use the input file stream object and we linked an input file to it, and we were able to use the file for input by calling the open function. And of course, right after the program execution, we close the file by calling the close function of the input file stream. On the other hand, cin belongs to the class of all input streams, but not the class of input file streams. Let's talk about inheritance and streams. Cin and input file stream are examples of input streams. Input file streams are members of the class input file stream, spelled as ifstream. Of course, such kind of input stream class can be connected to a file. On the other hand, derived from its parent class, which is the input stream, we have the cin, which is a member of the class iStream. Unlike the input file stream, it cannot be connected to a file. The input file stream is derived class of the iStream class, which is an input stream class. Now let's have a short review of the stream parameters. Looking back at our previous examples, we were able to see examples of functions which receive input stream as formal parameters, such as this one. It receives source file as a formal parameter, which is of type input file stream. Inside our function, we have two variables, which are assigned with values derived from our input file, from which their values will be added to produce the sum, which will be displayed using the cout. Hence, this code could be called using the following. First, we declare an input file stream. Then, we open the file connected to it. Then finally, we use that input file stream object as an argument for our function calls of toSum. However, the problem with that function is it is not versatile. What if we would like to use the function toSum and provide it with a formal parameter of type input stream such as cin? Since cin and input file streams are both input streams, this call to toSum seems to make sense. For example, we will use cin as the formal parameter for our function toSum. This may look okay, but actually it will not work. So how do we fix that? This is how we do it. This version of TwoSum will work with the cin. What we did is, we simply replaced the type of our formal parameter. If we will recall from the previous example, the data type of our formal parameter is input file stream. If that's the case, we cannot use cin for this function. Thus, to make it work, we change the data type of our parameter from input file stream to input stream. So this time, we can now use cin as an argument whenever we call the function TwoSum. Hence, this will now work. Now let's talk about derived classes and parameters. We now have this version of TwoSum, and this can also be called with an input file stream parameter, in which we open a file for input, and then we pass the input file stream object as an argument whenever we call the TwoSum function. So as you can see, we can use either cin or an input file stream such as fin as parameter for our new function. In this case, fin is of two types. This can be an input file stream, or this can be of type istream, such as cin. It also has all the features of the input stream class, plus added capabilities, since it is derived from a parent class, which is the istream object. Now let's talk about derived class arguments. A restriction exists when using derived classes as arguments to functions. For instance, a formal parameter of type istream can only use member functions of the istream class. Using an argument of type ifstream with a formal parameter of type istream does not allow using the open and close methods of the input file stream class. As you can see here, the input file stream class was just a derived class from the input stream class. Thus, whenever we are using an input file stream class as formal parameter to a function of istream, we must first open the files before calling the function. And of course, we close the files after calling the function, as what we can see in the previous slide. So you can see here, before we provide an input file stream parameter to our function, we first opened the file that is linked to this input file stream object. Hence, this will work. Talking about inheritance relationships, we have the following simple concept. If class B is derived from class A, class B is therefore a derived class of class A. Also, class B is considered as the child of class A from which it was derived. Also, class A is the parent of class B. As a result, class B inherits the member functions of class A. As a simple analogy, for example, we have the class mammal, and as a derived class, let's say we have dog. So which means that the class dog is a child class of the parent class mammal, which means that it automatically passes down the attributes or characteristics of a mammal to a dog. But of course, as a derived class, the new class dog has some of the attributes which are not automatically present in its parent class. For example, given the class dog, it is the only mammal that barks, and it does not automatically mean that all mammals can bark. Now, if we will put the same concept in inheritance relationships in programming, that is exactly the same concept that we observe in inheritance in the context of programming. Talking about inheritance and output, OStream is the class of all output streams. For example, cout is of type OStream. On the other hand, output file stream is the class of output file streams. The offstream class is a child class of allstream, which means the offstream class was just derived from allstream class, which is the parent class. For example, this function can be called with allstream or offstream arguments. So if we will take a look at this example, the concept is quite the same with the previous one, only that this time we are now using an output stream as formal parameter to our function. But the point is, this should work with both output stream and output file stream formal parameters. Here's another example. This example is derived from the previous example from 5.7, and if we will look back, the new line function from display 5.7 only works with cin. So let's have a look at the original program, this one. As we can see here, the new line function only works with the cin, which is an input stream. This time, we have a version which will work with both. As we can see here, we simply provided a formal parameter of type input stream. Hence, this will make it versatile. We can use either an input file stream or an input stream by simply providing the formal parameter that we wish to use. Now, if we are going to call the new version of our function newline, we can either call it, then provide it with an argument of cin, or provide it with an argument of type input file stream. If the original version of newline is kept in the program, this call produces the same result. Newline can also be called with an input file stream as an argument, such as this one. Now let's talk about default arguments. This actually will take us back to the concepts of functions, in which we provide arguments whenever we call functions that were declared with formal parameters. It may not be necessary to have two versions of the newline function. When we talk about two or more versions of a function, we are actually talking about overloading. But in this case, this may not be necessary for our newline function. Hence, a default value can be specified in the parameter list. And the default value is selected if no argument is available for the parameter. But how do we do that? Thus, the newline header can be written this way. So as you can see here, whenever we declare our function, this is where we provide our formal parameter. In this case, we assigned inStream as our default argument. And this time, in the declaration of our function, we provided the default value for our formal parameter. In this case, we used cin. So which means whenever we call the newline function without an argument, cin is automatically used since it is assigned as the default argument. We can also have multiple default arguments. When some formal parameters have default values and others do not, all formal parameters with default values must be at the end of the parameter list. So which means we must put an argument that is assigned with a default value as our last formal parameter. Arguments are applied to the formal parameters in order just as we have seen before. And the function call must provide at least as many arguments as there are parameters without default values. For example, if we have 3 formal parameters and the last one was given a default value, it means that whenever we call that function, we should provide at least 2 arguments, since the third argument has already been provided with a default value. Here's an example. We defined a function, default args, and in this case, it is provided with 2 formal parameters. So default args can be called with 1 or 2 parameters. So in this case, since it already has a default value for its second parameter, all it requires is that it should be at least provided with 1 argument whenever it is called, such as this one or this one. If we provide a second argument, that will override the default value for our second argument that was provided in our function definition. That's all for this chapter. And in this particular topic, you were able to learn the different types of cin and cout. Of course, the types for cin and cout are input stream and output stream, respectively. And you were also able to describe how to connect a stream to a file. So we do that by using the input file stream object and connect the file to it. Then we use the open function to use the file for input. And we were also given a short introduction on the concepts surrounding object-oriented programming, such as how to define an object and how to define a class, as well as derived classes, in which we were able to talk about deriving a child class from its parent class. And we were also able to list functions that format output. That's all for chapter 5, which is about I/O streams.